And welcome to the Desk of Champions.
Hey,
Lady Ada.
Hey, everybody, and welcome to another late Friday evening Desk of Lady Ada. Tony DeCola is on break holiday at Tour Camp, so we're going to be doing some electronics in his stead. He usually does his stream on Friday evenings.
That's right.
And tonight I thought we would have some fun. We get back into the circuit playground, and also tie this in with yesterday's video where we talked about and played with the Max 3100 pulse sensor. I thought we'd show how to make our own pulse sensor without needing a separate module. What do you think about that?
I think we should do that. I also think we should get to a little bit of news, though.
Okay.
So the news is, and we're going to talk about this during the week, is today we got news that you, Lady Ada, if you can go to this, if everyone goes to whitehouse.gov/champions, you'll see Lamore, Lady Ada, is getting an award at the White House. If you keep scrolling, she was one of 10 amazing people selected. Check out all the folks. Amazing to be in that group. And thank you everyone at Adafruit, our community, our team members, our friends, our customers, all the makers out there. This was because people sent in your name about this, and this is the people who are helping makers around the country and all.
Yeah, and there's some great stories. I didn't know about a lot of these people, and reading about what they're doing is really neat. And Adafruit we try to make sure that the tutorials and products and videos that we do are useful for the community.
Yeah.
And so talking to them, it might be, we'll chat with them and say, like, what kind of content do your maker spaces, do your students, do the people in your community want to see? And then if they tell us, okay, we want to see more of these kinds of projects, we'll do that. I mean, like, I love doing electronics in any sort. And if they say, okay, well, we want more wearable electronics, or we want more biosensing electronics, or maybe they want more video game type electronics.
Many of the people we're going to talk to them, and I know they use our stuff because they have maker spaces and fab labs, and they're doing 3D printing, and they're doing prosthetics, and they're putting electronics into prosthetics, and they're using all sorts of things. So this will be really neat. We'll be doing live coverage from the White House.
Yeah, I'm going to go there in a week.
Yeah, so that's coming up.
I can't take MOSFET though.
No, but
he's not an emotional support cat.
Yeah, let's do
let's do this video.
Let's do this video.
Okay, so we're already here. So this is the Circuit Playground. And I took a little bit of a break from Circuit Playground. We're definitely in manufacture. Everything's going great with it. It's our low-cost $20 electronics platform that I tried to squish as much useful electronics into. It has an Atmega 32U4 as the main processor, which has native USB, so it can act like a mouse. It can do MIDI, or it can act like an Arduino microcontroller. And you can get serial data through it. It's got 2 buttons, left and right. It's got a slide switch. It's got a piezo, which is kind of annoying, so I'm going to turn that back off. It's got a sound sensor over here. It's got a temperature sensor over here. And it's got a light sensor over here. An accelerometer in the middle, so you can also do motion and tilt and dropping and all sorts of tap effects. And then these are capacitive touch buttons on the outside, so you can do cap touch by connecting alligator clips. So it can act sort of like a makey-makey. You attach alligator clips to fruit or tinfoil or Play-Doh, and then you can sense that and turn this into an input device for anything that uses a USB mouse or keyboard. So that's kind of the overview. And we're starting to develop ideas in curriculum. Tony DeCola has done a bunch of tutorials on using Fermata, using the accelerometer to act like a mouse. And oh yeah, I keep forgetting there's like 10 RGB LEDs on the outside, which is actually what we're going to be doing a lot with. These are little mini NeoPixels. There's 10 of them. Not quite enough to make a clock, but because maybe you'd want 12. But still, you can display all sorts of things. And I actually like having these RGB LEDs because it gives you a lot of more colorful, fun output rather than having like a grid of LEDs. I decided to go away from the 5x5 grid that the Microbit and CodeBug have and say, okay, I want something that's more wearable friendly, that's more colorful, more maybe fashionable. So this is what I'm going to be playing with. And this is just the demo. The demo just lights up all of the LEDs and you can press the buttons and the serial console will tell you what it's doing. But what's funny is, yesterday we were playing with this sensor, the Max 3100. This is a pulse oximetry and heart rate sensor from Maxim. And this sensor has an IR LED and a red LED and a sensor in the middle. And it can do a little bit of processing and you can read the data through I2C. And we showed yesterday, and just check out the video, how when you put your finger on top of it, it can detect your pulse rate. And the way it does that is, can we go to the computer? I'm just going to totally abuse this diagram that they made. We'll have to redraw our own at some point, but it's a great diagram. The sensor, well, eventually they'll be like, hey, you can't use that. The sensor has 2 LEDs in it, and it lights up your flesh, basically. It lights up your skin and the meat of your finger. And the light bounces off and gets detected by a light sensor, which is then read by an analog digital converter. It reads the light levels. And your blood is, depending on whether it's oxygenated or non-oxygenated, so like venous blood or arterial blood, has different absorption of the different light frequencies. So red light has this absorption. It is absorbed, looks like it is absorbed more by venous blood. I don't know how you say it. The blood isn't oxygenated and then is not as absorbed by the oxygenated blood. And then IR is more absorbed by oxygenated blood and less by non. So, using these two, and you can subtract and do some math, you can figure out how oxygenated your blood is. And also, as the blood is pulsing through your body, the more blood you have, the more of that light you're going to absorb or reflect. And so you'll actually see a pulse with your heartbeat, because as the blood flows into your body, your skin gets a little redder. And we were talking yesterday, there's a couple of cool smartphone apps that you can point them at your face and your skin flushes just a little bit every second or so with your heart rate. And if you have a very sensitive camera, you can actually detect that flushing and it will tell you your heart rate. So that's kind of weird but cool. But what if you only want to do something, you don't have a very high precision camera? You can still do it if all you have is an LED and then a detector. So the pulse sensor from Maxim is kind of an all-in-one system meant for a smartwatch. But we also sell in the store this neat design called Pulse Sensor Amped. And it's a little pulse sensor that you kind of can stick to your finger. And it has a green LED. And next to it is a light sensor. Let's see if I can get a close photo of, I don't think I have a close photo, but you can see the green LED, and that is shining through the finger. And then right next to it is, I think it's this component maybe, or it's on the other side, is a photocell that detects the light. And so green LED, the frequency of light for green, also is very good at being absorbed by blood, or being reflected, I guess. And then you can see how much of it is being absorbed by your bloodstream, and again, that will tell you what your pulse rate is. So this is a very simple sensor that we sell, and people have used this for many years, and it works out quite well. It's designed by, I'm trying to remember the fellow's name, but he's really cool. Anyways, we've done a lot of projects with this, and it works nicely, and it comes with a little clip. This clip, and you clip it onto your finger, and then you'll be able to analog read the pulse rate. And what's funny is Phil B was working on this sensor to adapt it to the Arduino M0 because the code was written for the original Uno and needed a little bit of adapting to make it work with later Arduino microcontrollers. And he realized, hey, we could probably do this with a circuit playground. And so he actually adapted the code and says like, wow, this actually works pretty well. So just full credit to Phil B. I did not come up with this idea. In fact, after he said it, I'm like, oh yeah, that's right. I totally didn't think of it. That's a really good idea. So let's show how we can turn the circuit playground into a heart rate sensor.
All right, so how do you want to do this?
So just copy and then I'm going to write some code. And then after I write the code, we'll upload it to
Do you want to do a split screen or what do you want?
Well, can you focus just on this the screen here, this part?
You want to do some code?
Yeah, because I want it to be clear what I'm writing. Or I could just go computer only. That's fine too. Okay. So let's start by, you want to include the header file. This will get all your hardware ready to go. And then I'll just call this sensor circuit playground. And then in the setup, I'm going to wait until the serial console is opened. And then once it's opened, I will begin at 1500 baud. Again, this actually doesn't matter because when you use just pure USB, it doesn't matter what the baud rate is, but in case this gets ported to an Uno or something at some point, I like to clarify it does need to be pretty fast. And then I'll just print out what this is. And then circuit playground begin. Okay, and so what we're going to do is we're going to take advantage of the NeoPixel to make the green light. Because remember, you saw that pulse sensor had a green LED. So we're going to use a NeoPixel to do that. Can you go to the overhead real fast? I'll just point out which one I'm talking about. So this pixel here, the light sensor, well, it didn't really work out. Hold on. Close enough. So this is the light sensor right here, and this is the closest NeoPixel, and this is pixel number 1 because it starts with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up to 9. But it starts with 0. So this is the 0th one, and this is the first one. So we're going to set number 1 to be fully green. So let's write that code. Can you go back to the computer? Thanks. Set. So the only thing is I have to remember. I'm going to have my demo code here so I can remember how you actually set the color. Circuit playground.set pixel color. And then it's going to be the pixel 1, which is actually the second pixel. And then I'm going to set it to no red, all green, and no blue. So just green light out of this NeoPixel. And let's just start with that and just see how that goes. Just compile, 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 compile. And upload. Okay, cool. Can you go to a split screen? Thank you. Okay, so now when it's waiting for the serial console to open, but when you open it, you'll see it changed over to just have that green LED lit. Now the only thing is, for customer safety of eyeballs, I actually set the brightness of the NeoPixels in the constructor for the circuit playground. So I'm actually going to kind of undo that by above here after the begin statement. I'm going to add a circuit playground set brightness to 55. Because otherwise in the begin statement, I set the brightness to 20 so that first off, it doesn't use as much power, which would overload the voltage regulator. Or drain your batteries, and also won't blind people. So let's upload this new sketch, and you'll see this green LED gets much, much brighter. Bang. Okay, so much, much brighter. I mean, it's not that it's the brightness of the LED that's important, but NeoPixels, remember, they're not analog brightness controlled. They are pulse width modulated controlled. I don't want that pulse width modulation to affect the LED reading, because if you're pulsing the LED and you're trying to get analog reads, it's going to make the readings much more noisy. This way, if the LED is on fully, it's just like on all the time. Don't have to worry about any fluctuations. And then the loop is actually really simple. I'm just going to read the analog light sensor. So I'm just going to grab this code from over here, which reads the light sensor. Pretty simple, just serial print line circuit playground.light sensor, and that will do the analog read for me. It's just a cleaner way than trying to do analog read. And then I'm going to do a delay between reads. And a good place to start when doing heart rate, I've noticed, is about 50 hertz. So I'm going to delay 20 milliseconds. And I'll close this demo code. And this is the serial console. Okay, so you see, like, I've got signal streaming. It's about like, actually, as I move my hand over, the reflection of the light does affect the reading. But when I put my finger over it, it hovers around like 390, 400 or so. It's going to fluctuate. There's going to be some DC fluctuation. And the best way to read this, just like we did yesterday, is using the serial plotter. And the serial plotter is nice because instead of reading these numbers, I can actually see the value. And this is a nice addition in Arduino 167, I think, the Arduino IDE. So right now it's very noisy, and then what's interesting is as I move my hand over it, you do see the signal gets reflected. So you can actually use this kind of as a proximity sensor as well. As your hand gets closer and farther, you're going to get, as I get really close, the signal goes high. So you can use that. That's a way of, proximity sensors that you see, use that technique as well. But what I want to do is put my finger pad so that it is as close as possible to the photocell and also the green LED. So luckily they're just far enough apart that I think the light will reflect through my finger meat, but not so much that it will overload the sensor. And the real trick is actually don't put your finger down too hard, which is actually something that people tend to do. They really push their finger down, and that actually pushes the blood out of the way, which is not good. You don't want to like mash your hand down, because if you think about it, you do that, then your blood can't get into that zone. You actually want to be a little more gentle. And you'll see that there is, as I move around a little bit, there is this slow DC or very low frequency wave, but you can see the pulses of my pulse. So as the blood is moving in and out, you're seeing a peak to peak of about 25 points. So out of 3.3 volts, you can kind of figure out what that is. But it does work quite well, as long as you are standing pretty still. I wouldn't use this for hospital use, but for a student who might be interested in biology or medicine, this is kind of a neat way to see how electronics and medical sensing and biosensing go well together.
Yeah, this is neat.
Do you want to try it too? You want to see if you're alive?
Okay.
We're not going to get the cat.
No, we did that before. So.
Cat didn't like it. So yeah, just put your finger so that it covers both this light sensor. Yeah, like that.
Okay.
Yeah, you have a strong heartbeat. Look at that. Like even before it gets rid of this noise.
Yeah.
What's neat is actually you can see your double pulse. Like with mine, you can't. But see how you get the double bump?
Yeah.
Because you get the your heart, and then there's a little bit of a secondary pulse. So that's cool. I'm going to totally use you for the example video because of your great heart rate. Yeah, my heart's like weak or something. I don't know. Yeah, I have just like a single bump. I don't have a double bump. Very jealous.
Okay.
Okay, well that's kind of what I wanted to show. I thought that was kind of neat. So you can, use something as simple as a NeoPixel and this is the least expensive photocell available on DigiKey. This is like not a fancy part at all, but it works quite well. And so this is going to be another one of the projects that we publish about Circuit Playground. I think it's cool. We're coming up with a ton of really good ideas. If you give people the hardware, they can make all sorts of fun things.
Yeah, we're about to kick off our Circuit Playground series in partnership with Maker.io and DigiKey, so you'll see kind of the making of Circuit Playground. A question that came in the chat, and it's a good question, and we should probably do research if we don't know, but why are all the heart rate sensors that do this green? Why is the light green?
I think if you look at this graph here, it says red is over here and infrared is over here. It could be, and see how this is kind of going up. It could be that green is actually the most. It's the color that is. I'm so bad at color theory. So if something is.
Well, it's a complementary color.
Yeah, it's a complementary color, so it's going to be absorbed very well, and so that might be the color that has the highest absorption rate.
Yeah.
Or that
green will have the highest absorption rate. Yeah.
Yeah. So because it's like red means it's bouncing off red light, so green is absorbed, and so if that's true, then it could be that that's just the color that is the. First off, you're not going to be able to have any possible color with LEDs. You're stuck with, red, amber, yellow, light green, pure green, blue, and then white, which is blue with phosphor. Like you don't have every nanometer selectability, and so this could be that given the variability of LEDs, because I remember LEDs, you're not buying a single nanometer wavelength LED. There's going to be variation. Green might be the one that has the least issue with variation, but we can really quickly just let's try some other color.
Well, the thing is, I think what we're measuring is the green absorption.
Yeah, but it's of blood, and maybe your skin, because it's kind of reddish, it absorbs green. But what's interesting is the Max sensor doesn't have a green LED. It uses IR and red. So that's, which I think is, I don't think it's unusual, but I'm not sure why they chose to go with IR for heart rate. Could be that when you're doing pulse oximetry, maybe red and IR, like the difference between the two, allow you to. I don't know. When I write the lesson plan, I'm definitely going to look it up. The green is going to be because it's most absorbed by red. So let's go to the serial plotter again, and let's try red. Yeah, I'm not seeing. Yeah, with red, it's like you don't see any difference. Like I'm putting my finger on it, but it's reflecting the red light evenly. The amount of blood isn't affecting the red reflection. And then let's try blue, because I don't know, we're doing science here.
And then if you had a tattoo and you tried to do it, it wouldn't work as well. And I recall that happened with the Apple Watches that came out.
Really? Oh yeah, because the ink is going to block it. Yeah. What's interesting is people and putting
it's
this
just
against
the amount of light that'll be absorbed, and that's what it's measuring.
Putting it against your wrist is this. By the way, does not work against your wrist. It's very. This has no op amp. There's no filtering. It's just it was not even designed for this. This is a little bit of a nice coincidence. And so it doesn't work on your wrist, but finger works pretty well. Let's try blue.
Yeah. And then someone asked, was the sensor on the Circuit Playground intentional for that purpose? No.
Absolutely not. In fact, I felt a little bit foolish because I always saying I love biosensing.
We try to think of everything.
Totally didn't think of it.
But what's interesting is, I always think about the Arduino shields and how some folks said, oh, it'd be great if they weren't offset. But it made it so the shield can only be plugged in one way, which I think was a good idea. But it wasn't intentional. And I think that this is one of those for us where now we can do a whole range of tutorials and guides for biohacking, sensing, and more, even though that wasn't our original intention.
So here's the thing. So this is blue. So it does work.
Yeah.
But you can tell the signal's much weaker.
Yeah.
You can see that there's a pulse, but the peak to peak is only about like 10 points, not like the 25 or 30 that you get with green. So you do get a signal, but it's much, much noisier. Or it appears much noisier because the signal to noise ratio is much lower.
And that's one of the challenges with this method is there's lots of noise, and that's why on like the Apple Watch, for instance, it works better because it's covered up. It's next to you. There's no light noise.
The LEDs are insanely bright.
Yeah.
Like this is not even anywhere close.
Yeah.
There's multiple LEDs.
But that's why you'd use IR.
Yeah.
For instance, because it doesn't have the same issues.
So turn blue works okay. Red doesn't work at all, which is kind of what we expected. Green works the best. And then you can try different parts of your body. So what we might do when we write the tutorial for this is have the student try the different colors and show like, okay, green does work the best, and also try different fingers or different parts of their body. So what's interesting is thumbs actually, I haven't found thumbs work very well. Like I don't see a lot of variation in signal. First fingers work really good. And then ear lobes. Did you want to do earlobe cam?
Yeah, we can try. So
earlobe.
Yeah, let me switch here. Folks can see this crazy. I guess I'm gonna go to. I will go to this cam.
Oh, this is
all right. Oh.
Because I can't actually see if yes, you can see my earlobe.
Ding ding.
Still.
Friday night hacking.
Okay, still.
It's a hacker cam. All right.
Yeah. So. If I can hold still.
Oh, sure.
Which I'm not doing a very good job at. I got it working pretty well in earlobe, but I've always found that finger works better. Yeah, it's kind of iffy. All right, not so much.
All right.
It's easier with finger because you can see what you're doing.
There was like this David Letterman segment. I think it was like, oh, watch out for the whatever cam, and it was like all shaky.
Yeah.
But I forget what that is.
All right. Well, that's just the.
Here's like how the desk of Lady Ada runs. By the way, just like all this stuff here is just
craziness.
Like wires everywhere. This is how we roll on Friday night, folks.
Yeah.
This is it. There's no house cats here.
No.
No.
Okay. Well, that was kind of fun, and thanks to Phil B for noticing that this works out really well. I totally didn't think of it, and but once you mentioned it, I'm like, oh yeah, right. Like I just did some pulse sensing stuff, so this is a great time to show it off and experiment. So thanks, and people can look forward to seeing a tutorial on how to make a pulse sensor, and then you might be able to make a GSR sensor as well with the pins. Not like a really great one, but given that there's a 1 mega ohm pull up, you might be able to do something, I don't know, measuring skin response. Kind of tough though without an op amp. I think skin response is on the microampere level or a nanoampere level.
Okay.
Okay.
All right, that's it. Thank you, everyone. We'll be doing more over the weekend, and that's it. Thank you so much. We are supported by you, the viewer. Thank you so much.
Think about Circuit Playground. 10% off Circuit Playground.
Yeah. Let me see if there's
do we have a code?
I think Scanners is still working.
You try Scanners.
Yeah. I'll tell you.
Sorry,
if
I forgot.
true.
Sometimes you have a code that you.
Yeah, you can use the code Scanners.
Yeah.
10% off.
For Circuit Playground.
For anything really.
For anything.
Except for gift certificates and software.
If you want to write the code, that was like 5 minutes code. And you know what's really what I like about this is with the plotter, you don't need to like have any algorithms. Like, of course, we'll do a low pass filter thing and measure the pulse, but just to get people started with the light sensor and the Arduino IDE, that's like 5 lines of code. Just set it up, set the brightness, set the pixel, and just read the analog signal and print it out. Like, that's so cool. It's like one of the easiest projects you can do.
Yeah.
Yeah.
All right. Well, thank you, everybody.
All right. Good night, everybody.
See you in a bit. Bye-bye.